Hi there, my name is Amir. I'm an information security analyst. Today we'll be looking at how we can detect VPN leaks in our network environment. Let's get started off with the basics. What is a VPN, who needs it, and who doesn't? VPN stands for Virtual Private Network. It's used by many people all over the world who are privacy concerned. Maybe you don't want people to know what you're browsing on the internet, or maybe your employer or government censors parts of the internet and you need a way to bypass their firewall. Or maybe you're just security conscious and you don't want certain areas on the internet to know where you're connecting from. A VPN's main task is to mask your connection. That way, your real IP does not show when you connect to a server. VPNs are great tools, but like any tool, they are not perfect. VPNs are prone to leaks, and that defeats the whole purpose of what they're designed to do. There are many types of VPN leaks out there, but for our demonstration, we will be focusing on WebRTC leaks. WebRTC is a specification designed for sound and video communication. It's done between the browser and the service that the client is trying to access. WebRTC is used typically in JavaScript and embedded in HTML5. Most modern browsers like Chrome and Firefox do in fact support it. It's meant to be direct, that way there is a reduction in delay and latency. It's built in, so there is no installation or plugin. But because of its decentralized fashion, WebRTC can in fact leak your IP address. Many VPN providers don't protect their clients from WebRTC leaks, and that's what we're going to explore today. In this video, we will look at different VPN implementations and see just how secure or prone each one is to WebRTC leaks. Specifically, we will be looking at VPN web proxies, VPN browser extensions, and one of the most widely used, Tor proxies. For those who don't know, a Tor proxy is essentially a server that reroutes all your data through the Tor network. Let's get started. For this demonstration, I will be using Mozilla Firefox because this browser in particular has WebRTC enabled by default. If you remember from our last video, we used exploit.io to determine if our browser was vulnerable to exploits. Now I've equipped Exploit with the capability of detecting all sorts of VPN leaks. All you have to do is visit exploit.io and it will tell us whether or not we're experiencing a VPN leak. Before we do that, let's make sure this web proxy is in fact rerouting our connection. As you can see, this isn't our real IP address, but the address of the VPN provider, which means we are good so far. A web proxy is the most simplest form of VPN implementation. All you do is visit the site that has the web proxy service. In this case, we're using kproxy. Type in the site you want to visit, and it will automatically route all your data through its VPN service and display the content directly in your browser. There's no installation or anything in order to take advantage of web proxies. Now let's head to exploit.io and see if it could grab our real IP. As you can see, it's indeed routing all our traffic through its proxy, but it fails at protecting our IP address from a WebRTC leak. So now what? Well, one thing for sure, we should stay away from web proxies. Surprisingly, kproxy also has a browser extension. Let's go ahead and download it and then enable it to see if maybe that will protect us from WebRTC leaks. This browser extension is available on both Chrome and Firefox. I personally would never use a browser extension for VPN purposes, and you'll see in a minute just why. Let's use it to visit exploit.io and see if it's 100% secure like the extension advertises to be. Here I've already installed it. Let's go ahead and turn it on. Let's visit a site that tells us our IP address to ensure that we are being protected by their VPN service. According to this site, our traffic is indeed going through kproxy. Now, let's head back to exploit.io and see what it has to tell us about just how secure this browser extension really is. Even with the browser extension, we are still prone to WebRTC leaks. You see that right there? That's our real IP address. So now what? Surely there's something super secure that will anonymize all our traffic. Well, kind of. Ever heard of Tor? Tor stands for the Onion Router. It's essentially a network that bounces our traffic all over the world. And while it does this, it's also switching up the nodes we're using to connect to a service. Tor can be implemented in many ways, one of which is just by using Tor's own browser bundle. Another way is turning Tor into a proxy. That way, all our devices can connect to the Tor network without actually using the browser they supply. It's more of a plug and play. I don't need to configure anything, all I do is connect to the proxy. So right now, we're connected to the Tor proxy, and we can test that by simply visiting check.torproject.org. We are indeed connected to the Tor network. So let me ask you a question. Do you think this will protect us against WebRTC leaks? Because after all, it's routing all our traffic in every single port through the Tor network. Well, let's find out. We're now on Sploit using Tor. Sploit can actually detect whether you're using Tor or not. But unfortunately, it failed against the WebRTC leak test as well. You're probably wondering why such a secure network would fail against this. Well, you see, the browser that Tor supplies us originally isn't prone to WebRTC leaks because it's disabled in the browser by default. Tor's own browser has a bunch of things configured that way things like this don't happen. But due to the nature of WebRTC, not even a Tor proxy can help us against WebRTC leaks. A smart way to make sure that we're not prone to WebRTC leaks is to just disable it entirely. This can easily be done either through a browser extension, like so, or it could be done manually. I'll quickly show you how to disable it manually in Firefox. Simply visit about:config, and then you'll get a warning. Just go ahead and accept it and understand the risks. Then type this in the search bar, media.peerconnection.enabled, and disable it from there. If that's too complicated, you can always just download the extension, like so. Just go to Firefox or the Chrome Web Store and type in WebRTC, and surely something will pop up, like this. I already have it installed, and it's pretty easy to use. Let's use this browser extension to disable WebRTC and visit Sploit again. See, this time, Sploit wasn't able to pull our real connection info. If you look carefully, this is just like the Tor exit node that we used to connect to Sploit, which is perfectly fine. We're in fact protected from WebRTC leaks right now. Now, go ahead and see whether or not your own environment is prone to WebRTC leaks. Simply visit Sploit and hit the Run button and see the results for yourself. Thanks for watching, and see you next time.